Okay, these are homework problems from exercise 9I. The first one is question 6, B. So first you had to find the equation of the normal, is that right? So first you had to get the gradient of the tangent, then the gradient of the normal, then the equation of the normal using the point gradient formula. Now that should all be fairly good for you now. And then find the coordinates of A and B. A is just where it cuts the x-axis, B is where it cuts the y-axis, and it's that equation of that normal. So you're just substituting y is 0 to get the x-intercept, and x is 0 to get the y-intercept, okay? That should be good, okay? Now, part B, the question is to find the coordinates of C. Now it says C, comma, D is the fourth vertex of rectangle BOCD. Oh yeah, a bit of a yucky question. Well, if we've got I think it was the diagram, BOAC, girls, you just need, C would just have the same X value as A and the same Y value as B. Yeah, because it's a rectangle. So that's C. So it would just have the same, in other words, can you see how B and O and A there forms a right angle? So just AC, C would be directly above A and directly across from B. So the coordinates C will be the same X value as A and the same Y value as B. Yes. This is C, this is the X value of A, and this is the Y value of B. So that's the coordinates of CD. So you then have to show that C, which is this, is equal to D times T. Now that's what D is. If you times D by T, you're timesing the 2A by T and the AT squared by T, and you get 2AT, AT cubed. Now that is the same as C up here. They're the same. Yes. Okay? So girls, this is exercise 9J question 3. You've got the questions in front of you. The question is if P is a variable point on the parabola, 4t, 2t squared, on the parabola x squared is 8y. They said that the normal at P cuts the y-axis, so normal at P cuts the y-axis at A, and R is the midpoint of AP. So first sketch, girls, I'm doing part A. Part A says show that the normal has equation x plus ty equals 4t plus 2t cubed. Let's just find the equation of the normal. So first we differentiate and we get x on 4, and we've decided to do it from x squared is 8y. Then at P we find the gradient of the tangent. So what do we get? 4t on 4, which is t. So therefore, that's the gradient of the tangent. So therefore, the gradient of the normal is -1 on t. And so therefore, the equation, actually I might put it there. So therefore, the equation of the normal, girls, this should be very, you've done this so many times now. It should be getting, at least in these questions, you should be able to do all that beginning stuff. Equation of the normal, y minus y1 equals m, x minus x1, what do you get? Y minus, yep, equals -1 on t, x minus 4t. Girls, what do we do with that t? Yeah, it's much better to take it to the other side straight away. Get rid of that denominator. You're left with -1 bracket x minus 4t. I'm just doing every step. So therefore we get ty minus 2t cubed is -x plus 4t. Let's just rearrange it. I think they've just got the x on this side. They've kept the ty here. They've kept the 4t here, and they've taken the minus 2t cubed over. Anyway, girls, you actually get the mark for this line here, where the dot is. You don't get the mark for the next line because they gave that to you. You get the mark for the line, the work before. All right? So that was part A, to find the equation of the normal at P. Now show that R has those coordinates. Now what is R? It says R is the midpoint of AP. So R equals midpoint of AP. But do we know what A is yet? No. So A is the... It's a point lying on the normal, and it's on the y-axis, and all we know for y-axis, x is 0. So for point A, because it tells you that the normal at P cuts the y-axis at A, you must read the question. To find A, which is on the y-axis, you substitute x equals 0. Girls, with this, just read it, read it, read it. It's not as bad as what you think. What do? Substitute x equals 0 into the equation of the normal, into this. Yeah, if you substitute in x is 0, you're trying to find, see, A has an y value, like it's x is 0, y is something. So what do you think you need to do with this? You need to work out what y is. How are you going to do that? Divide by, so it's 4t over t plus 2t cubed on t. So y is, no, 4t on t. 4 plus 2t squared. So therefore A has coordinates 0, 4 plus 2t squared. All right, R is the midpoint of AP. What's P's coordinates? So therefore R is the midpoint. We okay, girls? So don't you go 0, add the x's together, divide by 2, add the, and then add the y values together, divide by 2. Now listen, this locus here is actually easier than the other locus in 2 unit. Part C is really easy of this question in a minute. So what's this? 4t on 2 is what? 2t. T squared plus 2t squared is 4 plus 2. We've got 4t on 2, which was 2t, then 4 plus, these are like terms, so 4 plus 4t squared on 2. So you divide each of those by 2. They're both over 2. So what do you get? 2 plus 2t squared. So they're the coordinates of R. Now, what? So R is up here. No, yeah, we did it. See, not that hard. Part C says, now, you know how, I'm going to draw it all again, because we can't see the diagram. We've got the equation of the, we got P, we got A, we've got R. Now, you know that P is a point, a variable point, which moves because it's variable. And it moves all the time. And P can sometimes, you're watching, P can move down here, but A's still, A, I think will, depending on the value of T, A will change too. No, it won't. Yes, it will. Because A is 4 plus 2t squared. So as P changes, so will A. Because P is 4t, comma, 2t squared. Sorry, I know you can't read that properly. All right. I'm going to tell you in a minute. What, for part C? Yeah, I'm going to. That's what I'm trying to explain now. You know, P moves all the time. So it'll move down here and all the way along there. And you know what? A will move as well with it, depending on what T is. See, if T is 1, point P happens to be 4t, 2t squared. So if P was 1, it would be 4, 2. If P is 2, it would be 8, 8. Like P moves. A moves as well because A has got coordinates. A will always be on here, but it'll move up and down, depending on the value of T. Now, R will also move all the time because it's in terms of T as well. So P has its path along the parabola. A is actually going to move up and down because it's always 0, 4 plus 2t squared, depending on the value of T. R will move as well. So R, you know, a moving point follows a path. That's called a locus. So part C says, show that the locus of R is a parabola. In other words, we've got to find R. Now, we know what a single point of R is. Now, to find the locus, girls, isn't R a point which is x, y? So x is 2t, y equals 2 plus 2t squared. If you want to show that that's a parabola, You just eliminate the parameter. You make t the subject and substitute it into the other, which was make it a Cartesian equation. So we're just now going back to our first exercise, which was make, to show that that's a parabola, you just make, yes, make it a Cartesian equation. So the last step you might think is hard, and you know what, even if you can't do the second part, because they say show that R is this, you can always do part C. So you have to show that this, you know how this is 4t, 2t squared, but you know it's a parabola because that's x is 4t, y is 2t squared, and you make t the subject and substitute it. We did it in the very first exercise. So to show, instead of having an x value and a y value, I want to make it y equals something x. So let's rearrange. We get that t is what? X onto, and substitute it into y equals 2 plus 2t squared, which is 2 plus 2 times x on 2 squared. All right, I know you can't see. So girls, part C, to show that R is a parabola, show R is parabola, locus of a parabola. All you have to do is find.
Sorry, Miss Megan.
That's all right.
Can we do a hard copy of the retest?
I've got it. I've got to get it off my desk. R is 2 points. You know how our parabolas, girls, when you go back and look at the question, the parabola is described two ways, as a point, variable points, and as x squared is 8y. How do you get the x squared is 8y? By making t the subject, because that's x is 4t, y is 2t squared. The way you go from that to that is make t the subject and put it in there, which is what we did when we first started this topic. So this is all it's asking you. So girls, you've done all the hard work in this topic. You just have to, so 2 plus 2x squared on 4, just be careful, expand the bracket first, which is 2 plus x squared on 2. Now, girls, that's definitely a parabola. This is not, so this is y equals, girls, think of it in terms of transformations. Isn't it a half x, isn't it really y equals a half x squared plus 2? Isn't it the parabola y equals a half x squared shifted up 2 units? Do you remember how we learnt about parabolas before? All the locus stuff we learnt, if it's y equals x squared, what does it look like? Like that. X squared plus 2 shift the whole thing up. So tell me what the focus of this parabola is. It's shifted up 2 units. So what's the, not the focus, what's the vertex of this parabola? Now what else do they want? They, vertex of this parabola. So they said show that the locus of R is a parabola and show that the vertex of this parabola is the focus of the original. So vertex of this parabola is that, because isn't our new parabola from R, wait, so like this, that y minus 2, that I wouldn't do it, is a half x squared, that timesing by 2, 2y minus 4 is x squared. This is how you want to do it, isn't it? But why? It's, and I'm still not finished. X squared is 2 bracket y minus 2. You want to do it like this, using locus. But why? What's wrong? That is, see girls, you should be able to look at that and recognise it from 2 unit as an x squared parabola picked up 2 units. Do you know what the half outside the x squared means? The width. Yes, they don't want to know the focus. They just want to know where the vertex. If it was just y equals half x squared, where would the parabola be? At 0, 0. Plus 2 means lift the whole thing up 2. Girls, I really want you to do it this way when it's this simple, because I'm really worried that when you get to the 2-unit exam, you're not going to remember anything about transformations of graphs. Girls, remember when we did lifting up, pushing down for anything, whether it be a parabola, a hyperbola, a cubic? If you've got plus 2, it means pick up your whole graph and lift it up 2 units. If you've got, you know, in the brackets, it's sliding, shifting across to the right and or left. Look, if you want to do it that way, that's fine. We've got 0, 2, but that's fine. But I think it's quicker to recognise that. Now, it says, show that the vertex, girls please, of this parabola is the focus of the original parabola. So over here, girls, the original parabola requires you to look at the question, read, original parabola is x squared is 8y. Georgia, what's the focus of that? Come on. 4ay. What's a? 2. Is this concave up? So what's the focus? 0, 2. So focus of original is 0, 2. Doesn't that equal the vertex? So we've got the original parabola. Looked at that. Read the question carefully. Has focus 0, 2. And the vertex of your new parabola, this is the new parabola. The vertex of the parabola formed by the locus of R has vertex 0, 2. So you can write a conclusion. Therefore, vertex of this parabola equals focus of original parabola. Girls, you know what you've got to do? You've got to pick in the question, what do I need to do? Show that the vertex of this parabola, work out the vertex of this parabola, is the focus of the original parabola. Work out the focus of the original parabola. R is the midpoint of this. Work out the midpoint of that. If you start following and picking out what the question's asking you, you'll see what needs to be done. But if you read it as some complicated mess, you're going to get nowhere. You do what it tells you to do, and you should be fine because it's actually not difficult. But you have to read the question. Exercise 9J, question 9. P and Q are points on that parabola x squared is 4ay. It says, and the chord PQ subtends a right angle at vertex 0. So, you know about subtending with circle geometry. So, at the ends of that chord, if you join them to the vertex at 0, you will get a right angle. That's what it's telling you. I've done that in red. So, because we've got right angle there, we're going to be using what? No, you're going to use gradients of OP times OQ is -1. That's what, whenever you see something like that, you are more than likely going to use that. Now, girls, it says show that PQ is -4. No guidance whatsoever with this question. Show that P times Q is -4. Well, girls, I would just try. They're not saying find the equation of chord PQ. They're not saying anything like that. No, it's not going to help you. You're going to end up with x plus ty, or py is something. I don't know what you're going to end up with, but you're not going to end up with PQ is -4. The only way you're going to get something like that is to do the gradient. If they want the equation of the chord, they'll ask you for it. So the only bit of unfamiliar, and you'll end up with y equals something x equation of a line. So that's not going to help you. What you should try is the gradient of OP times the gradient of OQ is, they're perpendicular lines. Girls, whenever you're told these two lines are perpendicular, that's the first thing you do. Gradient of perpendicular lines is -1. So I need the gradient of OP. How do I do that? Isn't it y2 minus y1? So I'll just work that out. Gradient of OP is what? y2 minus y1 over x2 minus x1, which is AP squared minus 0, because that's the point. 2AP minus 0. Let's simplify it. AP squared on 2AP is what? The A's cancel. One of the P's cancel, you get P on 2. If you forget the zeros, they're non-existent. A P cancels with one of those P's and the A's cancel. You're left with P on 2. Now, what's the gradient of OQ? You don't have to work it out.
It's Q on 2.
It'll just be Q on 2. So it's going to be I would just go minus 0 over 2AQ minus 0. It's going to be Q on 2. You can see you're going to get the result, can't you? P on 2 times Q on 2 is -1. Why? Because OP is perpendicular to OQ. Therefore, PQ on 4 is -1. Therefore, PQ is -4. Girls, if they want the equation of the tangent, they'll ask you for it. If they want the equation of the normal, they'll ask you. If they want the equation of the chord, they'll ask you. But in something like this question, show that PQ is -4, it's got to be something a bit simpler, not as involved. They always will guide you in each part, show that this is that. So the only thing you can do here was gradient. All right, part B. Show that the coordinates of the midpoint, M of PQ. Is it asking you for the equation of PQ? Do you need to do it? M is the midpoint of PQ. How do you find the midpoint? Add V. So we want, we just, midpoint of PQ is M. Okay, girls, this is not hard. It's not hard. If you had normal points for P and Q, you can find the midpoint. Don't look beyond the A's and the P's and the Q's, all right? So, 2AP plus 2AQ over 2, comma, AP squared plus AQ squared over 2. You need to factorise, girls, or you say I'm dividing each of those. Now, look, they've done some, they said show that they've done some factorising, so let's do that. What can you factorise out? 2A can factorise, bracket P plus Q on 2. What else can factorise out here? Just A. Now, P squared plus Q squared is not a difference of 2 squares. It can't be simplified. What can cancel? The 2's cancel, and this is what the answer is. A bracket P plus Q, comma, and then it says a half A. That's the same. A on 2 is a half A. No. Oh, that's here. Because normally you put points in brackets. So, girls, that's not hard. I'm going to write down this next question. It says use the identity, use the fact that P squared plus Q squared equals P plus Q squared minus 2PQ, we know that, to show that the Cartesian equation, so they're just asking for the Cartesian equation of the locus of M is x squared equals 2A bracket y minus 4A. All right, we'll start with that. I don't mind if we use that at the end or we start with it. Let's just use it at the end maybe, otherwise it's going to get a bit long. So what should I start with? Don't worry about that result yet. We'll use it when we need it. What do you do with part B? We're trying to find the Cartesian equation of the locus of M. This is M. M changes depending on the values of P and Q. So how do I find the locus of M? Yeah, I can. I will soon, but not right yet. All right, how do you find the locus of M? Isn't M x is A bracket P plus Q? All right, got it? So isn't M the point A bracket P plus Q? Y equals? I don't like the half. I'm going to do A bracket P squared plus Q squared on 2. I don't like the half, all right? I like to know what the denominator is, and it's 2. All right, how do you pretend if that was a T, I know you've got a P plus Q, but if that was a T, yeah, I've got to I'm trying to, when I end, so isn't P plus Q equal to X on A? So, and then I'm going to sub that into, don't worry, yes, and that's why I've got to change it. So, over here, I can't put P plus Q in there, but why don't I change how Y looks now? You know how they're saying using that result? So no, because you can't. So, I've got X on A is P plus Q, but I can't put it in there, so let's use the result I got. What do you replace the P squared plus Q squared? P plus Q all squared. Now, I need double brackets here. minus 2PQ.
And then we know that PQ is negative
Can we
4.
expand it? Because I'm just worried we're going to lose it.
Then we know that PQ equals negative 4 as well.
Yes, we do. Very good. So we've got A bracket P plus Q squared. See how A is being, and over 2. So isn't A, and then we replaced all of that P squared plus Q squared with that. So we've got A times P plus Q squared minus, what do I do? 2APQ over 2. That's what Y is. Now, let's sub, which is A, P plus Q squared minus 2A times negative 4 over 2. I'm just going to go sub PQ is negative 4. And we get A, P plus Q squared plus 8A over 2. A times whatever P squared plus Q squared was. So I've replaced this with that. Now it's A times both of those. So we've got to expand our brackets over 2. And then we've used the result that PQ is negative 4 in here, and we've got that. Now we can sub P plus Q equals X on A into that. So this is Y equals A bracket X on A squared plus 8A on 2. Well, AX squared on A squared would be what? X squared on A, I think, plus 8A all on 2. So let's just do one step at a time. We don't want to ruin this. Now, if you're dividing... All right. No, you could. We can take the 2Y over. I'd be wanting a bit of a common denominator on this top row. Let's just take the 2 over and get rid of it. 2Y is X squared on A. Wait a sec, girls. Sorry. You okay there? I'm going to take this 2 over there because I don't like denominators over denominators. We might have to bring it back later. I'm not sure. So now what are you going to do? Multiply through by? Yes, girls, they're saying show. This is what you're trying to do. Show that you get X squared is 2A bracket Y minus 4A. This is the question.
Yes, just hold on for a second. Isn't it Y equals AX squared over A? Because it's times A to the...
Yeah, but you get A, X squared on A squared.
One of the A's cancel.
One of the A's cancel.
Did you skip a...
I've skipped a step.
Okay.
Actually, all right, I'll write it AX squared on A squared. There you go. Which is X squared on A. So I've put it back in. So I've got A, X squared on A squared, and then this A cancels with one of those. And then let's move the 2 over there. And we get, and let's cancel some A's. And you get X squared on A plus 8A. Now this is what we're trying to show. It's over here. It'd be good to get rid of that A, wouldn't it? Times through by A, you get 2AY equals X squared plus 8A squared. All right, let's take the 8A squared. See how it show that X squared is that? Let's just keep X squared on its own. 2AY minus 8A squared. Pull out 2A as a common factor. See, girls, look at what you're trying to show. Just want X squared on its own. So take that over the other side, but we like to put X squared on the left. 2A bracket Y minus 4A. That's done. Now this is the tricky bit. Describe that locus. I traditionally put this in an exam, but describe it. You know how it's X minus, isn't this of the type? Yep, good. Equals, it's this type, isn't it? It's that type. So, but see how 4A equals 2A? They're different A's. So what I do, oh God, I hate this. Oops, wait a sec. So girls, if you look at this parabola, it's of the format X minus H squared equals 4A Y minus K type. This is a parabola, concave up, vertex 0, 4A. Now, we're trying to equate this with that. Now we know that 4 times A means 4 times the focal length. This is how I do it. I go 4 times the focal length, because A is the focal length, equals 2A. So the focal length is A on 2. So therefore, your parabola has vertex 0, 4A. So we better draw it. 0, 4A. Shh. So this is the point 0, isn't that the vertex? 0, 4A. If the focal length is A on 2 units, A on 2, what are the coordinates of the focus? Here, I'll make it bigger. All right. So we've got vertex 0, 4A. Focal length is A on 2 units. So this is the focus up here.
0 and 4A
Plus A on 2. Good. So the focus is 0, and whatever this Y value is plus that extra bit of A on 2. 4A plus A on 2. Girls, isn't that 4A plus half A?
Yeah.
A on 2 is a half A. So it's 0, 4.5 A, or 9 on 2A. 9A on 2. Because it's 4A plus A on 2 is a half A. 4 plus a half is 4.5. Or you can do common denominator. 8A plus A on 2 is 9A on 2. Okay, so this is a parabola concave up, vertex, focus that, vertex 0, 4A, concave up. Hard. Tricky.